So to continue with factoring by grouping, the nice thing is that it really works no matter what. For example, this, you may realize, or may one day start to realize, that that is a perfect square. I have 3 squared here, and I have 2 times 3 here, and that fits the pattern. Alright, so that's my 9, and this is my 6x, and this is my x squared. But if you don't see that, right, same thing. 1 times 9, my product of the first and last coefficient, 9, and I'm looking for 2 factors of 9 that add up to 6. Then I've got x squared plus 3x plus 3x plus 9. And already when you come to this step, this only happens when you have a perfect square. So that might start to be your tip-off. But even if you get to this point, you can take out x and x plus 3, and then 3 and x plus 3, and you'll end up in the same place. Alright, so no worries if you don't recognize perfect squares. You will see that when you factor by grouping. Might be less obvious if it's negative, but here 1 times 9 is 9, and then realizing this is negative, you can recognize that 9 can come from negative 3 times negative 3, and that would add up to negative 6. So that would work out the same way. So going back to factoring special products, here's another one. Okay, ideally you start to realize if I have a perfect square here, right, this is 4x squared, and a perfect square here, this is 5 squared, then this is equal to 4x, this one, plus 5 times 4x minus 5. So that's 4x squared, or 4 squared x squared, or 16x squared. I meant 4x squared in parentheses, but I know verbally it doesn't sound like that. And then my minus 25 here, and having the exact same terms, a plus here and a minus here, means I have 20x here, and exactly the opposite, negative 20x. So those will cancel out, and therefore there is no middle term. So my coefficient of x is, in other words, 0. If you don't recognize this pattern, this is called the difference of squares, because there are 2 squares, and they are being subtracted. In other words, the difference is being found. If you don't, that's okay. You can find this product, include the negative there, the coefficient of x squared, and your constant term, a and c, if you think of the 3 coefficients that way. It is negative 400. The calculator would help, but right, 4 25s is 100, and then I've got 4 of them here, so negative 400. And I want that to add up to, interestingly enough, the middle term. It's just that the middle coefficient, b, in this case, is 0. So I want to find 2 numbers that are exactly the same and opposite. So 400 is 20 squared, and I have one of them negative. Well, that works. I mean, you could go through all the factors, or typically in this sort of a situation, this number will be a square, or the absolute value at least will be a square, and it will be negative in this situation where you have a difference of squares. So you will have the negative square root and the positive square root of that number. Once you get to that point, you might already recognize, oh wait, I am dealing with a difference of squares. If you remember over here, they were either both 3 or both negative 3, and so you had a square, perfect square, binomial. Over here, one is negative and one is positive, and so you have this situation, the difference of squares. So if you don't recognize it here, you might recognize it here as you're doing factoring by grouping. But even if not, you can keep on going. Minus 20x plus 20x minus 25, and split that in half. I can take out 4x, and I have 4x minus 5, and then I want to take out 4x minus 5, and of course that is plus 5. 20x and minus 25. So then factor out 4x minus 5 from both terms, and voila, there we go. Alright, this one is another perfect square, and we can run through it, or not another, I think the first one in this video was a perfect square, and this one is too. And you can also do that factoring by grouping, or maybe you recognize this is 5 squared, this is 2x squared, and then to check whether or not this term fits, you would take 2x and 5, which is 10x, double it, and it indeed fits. As long as this is negative 5 squared, then this is negative 5, that's negative 10x, and that's negative 20x. So then this is 2x minus 5 squared. So recognizing these without going through the whole factoring process is all about taking note when you see terms that are perfect squares. 25, 9, 4, 100, 36, and so on and so forth. Of course, if not, you may factor by grouping. It will work. In this chapter, we're not doing quadratics that don't factor, but again, this is a really good way to make it very clear that something is not factorable. Trial and error, you're always kind of not sure if you're missing something. But this way, if no pair of factors adds up to the middle term, then this is not something that you can factor, at least not by hand, not with, sorry, that's incorrect to say. You can factor it by hand. It just won't end up with nice, neat integer numbers. Okay, so 4 times 25 is 100. We can list out factors. I'll just be thorough, even though you know 1 and 100 are not going to get you to 20. So you can always jump to the ones that you are more positive about working. 10 and 10. Okay, and then that's pretty much it. Once you get to the square root of whatever that number is, you are going to go back the other way and start repeating. So you can stop there. So, yep, 10 and 10. And to get negative 20, they're going to have to be negative, which we can do because negative 10 times negative 10 is 100. 4 times 25. Alright, so that works. Minus 10x plus 25. And we'll just do some more factoring by grouping. Okay, and so you can see, yeah, this is 2x minus 5 squared.